Welcome to our simulation for our ALU. It will take in two 4-bit values, and based on the output from our finite state machine, it will produce an output that is correlated to an operation that we have defined in our ALU. So here is our ALU component, and it has 4 different operations that are assigned to a selector value. Now, where do you get the selector value? I'll tell you. You go to your finite state machine, which will output, based on the state that it's in, a select value that is sent to the ALU. In this case, when our select value is 0, 0, we will do an AND function on A and B. When it is 0, 1, we will do an OR function. When it is 1, 0, we will do an XOR function. And when it is 1, 1, we will do a NOR function. Otherwise, it will be an output of 0, 0, 0, 0. So here's our finite state machine. Something that we need to take note of is when the reset is on, then we will be sent to state 0. And because we don't have any inputs, and that means that it will go into each state in our test bench. So we should expect when our reset is on, and if it goes to state 0, 0, that the select value will be 0, 0, and an AND function will be performed. Here's our top module where we create 2 components, one for our finite state machine and the other for our ALU. We create instances for both of those, port our top module to our components, and here's our test bench to test the top module as a component. We will be testing 2 different values, 2 different sets of values. For value A and value B for our first part of our test bench, we'll be testing the number 10 and the number 15. And then for our second part, we will be testing the number 2 and the number 12. So here's our wave form over here. Because our FSM goes through each state, we're going to start at 0, state 0, state 0, which becomes state 1, which performs our AND function. So you have 0 and 1, that should be a 0, which we get. 1 and 1, that should be a 1, which we receive. 0 and 1, you should get 0, and 1 and 1, you should get 1 for our AND. Once we hit a positive edge trigger on our clock, which our clock is right here, we will then be performing, because we're going to the next state, an OR function. And OR basically means that if there is a 1 from either input, then there should be a 1 as the output. We see here that there is a 1 for each index, which means our output should be 1, 1, 1, 1, 1, which it is. So once we go to the next state, we should get an XOR function. And so for our XOR function, the way those work is if it's a 0 or 1, then we're going to get a 1 as an output. If both inputs are the same, we should get a 0, which we see here. The 0 and the 1, you're going to get a 1. 1 and 1, you should get a 0, which you do. 0 and 1, you're going to get a 1. And then 1 and 1, you should get a 0, which we do. For the last state, on the positive edge trigger, it should be a NOR function, which means it should be the opposite of our OR function as a not OR. So that means if there is a 1 in the equation, then there should be, out of the 2 bits, then there should be a 0 as an output, which we see here, 0. So we're going to test our next states. It's going to continue to go through each state, so this should be the AND, OR, XOR, NOR, AND, OR, XOR. So when they change, we should expect for this to be the XOR output because we're going through the states. So when, as I said previously, when an XOR is used, if the 2 inputs are the same, then we should get a 0, and if they are different, then we should get a 1, which we see here. 0 and 0, you're going to get a 0 because they're the same. 1 and 0, 1 and 0, 1 and 0. You should get 1s. So that should be your correct output for these 2 separate numbers, and the numbers 2 and the number 12. And that's what you get here. So, oh, and this is the number 14, which said that, but whatever. Okay, so anyway, you go to the next one, and you should get your NOR function. Your next state should be the NOR function. And it is right, so 0 and 0, because there is not a 1, you're going to get a 1, which you do. 1 and 0, 0 and 1, and 0 and 1. Because there is a 1, the way the NOR works, you should get 0 outputs, which you do. And so we know that that state works here for this number. When we go to the next, we should be expecting, we're going back to our AND state, so we should get the AND value of these two values. So 0 and 0, you should get a 0. 1 and 0, you should get a 0. 0 and 1, 0 and 1, you should both get zeros, which we do. And then to test the last OR function, here, 0 or 0, you get a 0. 1 or 0, you should get a 1. 0 or 1, and 0 or 1, you should get 1 for both of those. So we can tell that our finite state machine ALU combination works correctly, as we can see by our wavelengths, and we tested 2 different sets of 4-bit inputs. Thank you for when our reset is on, it takes us to state 0, 0, 0, which if we look at our code, should take us to, well, should send a select value of 0, 0, which is our AND function. And so when you AND these two values together, 10 and 15, you should get 0 and 1 is going to be a 0, 1 and 1 is going to be a 1, 0 and 1 is going to be a 0, and then 1 and 1 is going to be a 1. So it shows that our reset value is working, and that stays consistent while the reset is on.